Hi friends, today I'm going to discuss about a hot topic in industry, and that is platform engineering and developing on IDP, that is internal development platform, and how it can cater to your need for having self-servicing everything. So the IDP, how it can uh, leverage the GitOps principle, and how it can help you to reduce the dependency on different experts, so that one developer or one tester, if he needs one uh, environment or any cluster or any database, okay, he doesn't need to depend on anybody. Rather than he can consume the APIs and services exposed by those experts, and he can create those resources on his own. So that is the idea behind IDP. Okay. So to do that, here I am going to show you or demonstrate one POC that I have just created. I have taken the reference of DevOps toolkit from Victor Farsik. He generally works in this area, and I've gone a little bit ahead and created a POC, and I have created a cluster in Kubernetes, and how that cluster can be created by any layman. He can just click a button and he will create that cluster, and whenever it is done, his task is done, he can go and delete that cluster on his own. Okay. He doesn't need to know the intricacy behind creating or configuring the cluster, and also how it is achieved using GitOps principle. Okay, we'll look into that. Okay. So the platform engineering IDP concept, the central uh, controller, you can see, is a control plane. Okay, and that control plane that controls everything. So the layman, the different teams will interact with the control plane, and the control plane will take the responsibility, interact with different tools, and does its task. Okay, so that is the uh, procedure or process that we are going to follow. And in my case, the control plane is uh, inside the Kubernetes platform, and it is the crossplane. Okay, and crossplane will be interacting with the different platforms like AWS, the DB, the secret manager, the Kubernetes cluster itself, the repo, okay, and also the uh, uh, different components inside the Kubernetes cluster itself. Okay. And one person will be interacting with the control plane through APIs or GUI. Okay. So the crossplane provides something called as composite. Okay. So those are nothing but the CRDs, custom resource definitions, and those custom resource definitions will be just like templates. And whenever you are requesting to create one resource, you are just sending one composite request. That composition request, okay, will be mapped to the CRD, and that CRD will decide now which kind of resources to be created. Okay, so suppose you are sending a composition, okay, to create one Kubernetes cluster. Okay, so you don't need to specify everything, but you need to specify what kind of cluster you want, in which cloud you want, what should be the node size. It will be a small cluster, medium cluster, or large cluster. So those basic things that you need to specify, and that request will be sent to control plane, and then now the CRD will come into picture and it will apply those changes to the target environment. So your desired state, okay, will be now applied to the actual state. Okay, now whenever this person is requesting something to create a cluster, okay, at that time it will be done through one GUI. So in my case I have taken port as my GUI. So this guy will get a button to create one cluster, and once he does that, one GitHub Actions flow will be running. That is a pipeline, and that will be pushing certain changes to the repo. Okay. Now the Argo CD or Flux, any GitOps tool that is uh, continuously monitoring this repo, which is the desired state. Okay. It will find that something is changed here, and it will apply those changes to the control plane. So control plane now knows that there is some composition available, okay, which is not there in the actual state. Now it will take that composition, apply to the actual state. That is the Google GK platform maybe. Okay. So the main benefit with crossplane is two-way synchronization. Okay. So here, whenever you are creating a cluster, suppose it is a 3-node cluster, and you are coming and deleting that particular, or deleting a particular node from that cluster, then crossplane can know that something has been changed in the actual state, which is different from my composition, and it will revert that back. Okay. And here Argo CD is monitoring the repo state. Suppose you are changing something in the repo. Suppose you are making the 3-node cluster to a 4-node cluster. Then Argo CD will monitor that, and it will check the composition here. That composition state is different than what is there in the repo, and it will apply that change to the control plane again by the form of new composition. And now the composition again will be applied by cross plane to the actual state. Okay, so that is the main concept. Okay, so we have a control plane which is cross plane, we have a user interface which is GUI. Okay, we have Argo CD tools for our synchronization, we have cross plane for our backward synchronization, we have a secret manager. Now secret manager, where you can store secrets, that can be done in two ways. Either you can encrypt those secrets and maintain it in a GitOps way in your repo. Okay. So there are tools available for that, like the Bitnami is shared secret. You can encrypt your secret and put it in your repo. Okay. And the same flow will now be applied, the GitOps flow, and it will be pushed to your actual state from your desired state. Now the other way is the more secured way, and in which you maintain your secrets in an external secret operator, okay, which is outside, like secret manager in Google suppose, and your control plane will be having one operator that will be continuously monitoring your secret store, and that will be pulling that information which is there in the secret store. Okay, suppose you have an image pull secret and that expired, and you are making the applying the new token to the image pull secret uh, in the secret manager store, then that will be uh, continuously monitored by the operator, and it will detect that change and it will pull that. Okay, now the benefit here is your client, your pipeline, or anything which generally you use, okay, to know the server credentials so that it can apply or push the changes to the server. Okay, so that stage you are eliminating. Rather, the control plane is connecting to all the different tools by knowing their credentials. So the server knows the credentials of the clients, but the client never knows the credentials of the server. So that is another benefit that you are getting with this. Okay. So now we'll take a pause, and then probably will go and look into the POC. Okay, now let's look at the different components in the demo. So this is my port, which is my GUI, and this is my GitHub. This is my Argo CD. Okay. Now I need to the developer. I am a developer and I want to create a cluster. Okay. Now this is my port, and the port is integrated with my Kubernetes cluster and also the GitHub. So there is a GitHub app for port that you can install in the GitHub, and port is basically a competitor to Backstage. So I'll not say which one is best and which one you should choose. Okay, rather than it depends on your expertise area and your need. But port uh, doesn't require any kind of JavaScript knowledge, where Backstage does require, and that is the main difference that I can say. And it is quite easy to use, though it is not yet advanced to that extent. There are still some weak areas where the port teams need to work upon. But I must say that this is the way, or this is the future way to go. Okay. You should have a GUI which you should expose to your different external teams, and this is the abstraction area, and they should only be knowing about this UI rather than understanding the intricacy of different complex tools, because that is not their expertise area. So here you can see you have the cluster, and it has different environments. Now in the self-service, you will find different actions like this: create cluster and delete cluster. Okay, for now I have just created two actions to simplify things. So now whenever this particular developer wants to create one cluster, he will just click on the create button, and he will just give a name that my GitOps GK. Okay, and provider is Google, and I need a small cluster. You want to have a small, medium, or large. Based on that, the node size will vary. Minimum number of nodes 1, and so the cluster will be either Azure or Google, where you want to create that. Okay, so this is my Google cluster, and now I'm going to execute this. Okay, so whenever you are going to execute this, the different background processes will start. Okay, now I have certain actions. Okay, GitHub actions. One GitHub action will be triggered. So there are different ways. Means if you want to go directly the GitOps way, we can do that, because now GitHub has provided the provider for crossplane, using which you can directly create repos using that provider in crossplane itself. So that is purely knative way, and you don't require to run one pipeline to create a repo. So what I'm going to do here, when this developer will click on the execute. Okay. Now here you can see the action has already been triggered. So there is a create cluster. Okay. Now this action, what it does, So it will go here and create these two files. Okay, so these two are the required files to create a cluster. Okay, and this infra folder is monitored by this Argo CD. So if you go to this one, so it is constantly monitoring that particular folder. So any new changes, new YML is put inside that folder, then it will start syncing that with the actual cluster. Okay. So now in some time the process will start and try to sync. It will see that the actual state is not as per the desired state, and it will try syncing it. Okay. It will take some time. So to avoid that, maybe I can go and apply force the synchronization as well. Okay. So now it sees that it is out of sync, and what it does, okay, so it is trying to create that particular that cluster that we asked for. Okay. So my GitOps cheeky, so it analyzed that, and now if you see here, so I'm going to look into my cluster now, set up clusters. So you can see here that it had started creating a new cluster called as my GitOps CK that we just ordered from here basically. Okay. So as I explained earlier, you can see here the developer, he doesn't need to know the any intricacies, he doesn't need to understand Kubernetes, he doesn't need to understand um, how crossplane works, how the Argo CD works. Okay, so he only needs to create the cluster, and he came here and clicked here, and the internal process started. The GitHub action started. It created some items in the repo. Then Argo CD detected those, and then Argo CD pushed those changes to the actual state, and now you are looking into the cluster. The cluster is getting created here. Okay. So we'll take a pause and come back when the cluster has already been created. Okay, now the cluster is already created, but I had given some wrong range, so it is not scheduled. So what I am going to do, this is just one example, so you can have your own set of node pools and you can define it properly. But now what I am going to do, I am just going to delete this cluster. Okay, so this guy will come here, and he will select the name of the cluster. Okay, so which will be my GitOps GK. Okay, now he will click on delete. Okay, once he will start clicking this delete, then again means if you go to the actions, then the delete cluster will come into picture, and then it will delete those files from the infra folder. Then the sync will happen, and then once the sync will start, then these resources will be again deleted. Okay, so we'll wait for the delete cluster to trigger. So maybe I'll do a sync manually here. Just avoid that wait. So once that will start, then here the delete of the resources will also start, and it will be visible here. Now the sync has happened, and you can see here the cluster is now being deleted. So in some time the cluster will be deleted. So this is the whole flow. So you are basically abstracting the intricacies or dependency on different experts. So your teams, they need to concentrate on their tasks. They don't need to understand and learn everything. Okay, and that is the main idea behind IDP. You are abstracting the complexity, you are abstracting the dependency, and you are establishing a clear flow. And this is the perfect example of implementing GitOps in platform engineering. So you can have your deployment in this way as well. So any kind of deployment, if you want to have, suppose you have multiple environments for specific teams, and whenever they start working on certain release items, they just need to come to this UI. They will click on certain button to create their own environment. So all the environment namespaces will be created, the deployment will be done, and they will have the application ready, and they will start doing the testing. Whenever they are done, they will come here and delete the environment. The namespace will be deleted. So in that way, you are also preserving your resources. So you are not consuming, or you are not blocking resources for later use. Rather, you are creating those dynamically, and thereby creating a huge amount of cost. So those things we'll again discuss. We'll come up with different use cases and different scenarios that where this IDP can be applicable. So those things are for some future sessions. Thanks for watching, and also let me know your views on this, and what areas you want me to create this kind of videos. Thank you.